In part 3 of section 3.5, let's transform not one of our toolbox functions, but a different function, and specifically the graph of a function. So the particular graph that we have has 3 specific points. And what we're going to do is transform or shift each of those points and then draw the shape back in. Again, the overall shape is not going to change. Now the proportion might change if we stretch it. The orientation might change if we reflect it, but the overall shape is going to look like that every single time. So part A, and what the directions say is the graph of the function is shown. Use the graph of f to sketch each of the following graphs. So we're going to graph y is equal to f of negative x. So to analyze what's going on, that negative is on the inside. The inside always changes the x direction. And what this is going to do is change the sign of each of our x's. So it's going to flip this thing left to right. So I'm going to make myself a note that we're going to change the sign on x. Okay, what does that mean? Well, that means the point that is over here at negative 2, 0 is now going to be over here at positive 2, 0. The point that is at 0, 2, well, the 0 is the x value and negative 0 and positive 0 are the same. So that one's actually not going anywhere. The point that's at 2, 2, if I change its x value, is now going to be over here at negative 2, 2. Then I draw in my shape, and there it is. So you'll notice again, the overall shape of the picture didn't change. We simply did a reflection across the y-axis. Pretty slick. I think these are kind of fun. In general, most students catch on to it pretty quickly. Part B says y equals f of x plus 4. So we'll notice that this is outside. And again, it's outside because it's outside of the f of x notation, which means it's changing things in the y direction. So we're going to add 4 to each y value. Again, if it's outside, you do exactly what it says in the y direction. So that's going to go back to the original graph, which is right here. We're going to take each of our y values and add 4. So the point that's at negative 2, 0 is now going to be at negative 2, 4. So negative 2, 4. The point that's at 0, 2 is going to go up there to 0, 6 because I'm adding 4 to the y value. So 2 plus 4 gives me 6. The point that's at 2, 2 is now going to be over there at 2, 6. Because again, you're adding to that y value. So the picture looks something like that. Pick the whole graph and moved it up. Part C is what if we have y equals f of x plus 4, f of x plus 4. So we're going to say, well, this is inside. And again, it's important to see the difference on where that 4 is. This one's inside because it's inside the function notation. It's inside the parentheses. So because it's inside, we know it's going to change things in the x direction, and inside means do the opposite. So instead of adding 4, we're going to subtract 4 from each of our x values. So the point that's here at negative 2, if I subtract 4, I'm going to be 1, 2, 3, 4, 5, 6. I'll be over here at negative 6. The point that's at 0 is now going to get moved left 4. So it's going to be at negative 4, 2. The point that's at positive 2, if I subtract 4, is now going to be at negative 2. So negative 2, 2. And you don't necessarily have to label the points. I'm just doing it to help you in understanding what I'm doing. There it is. So there's the transformed function. Nice. Hopefully you're doing okay and catching on. There's one more part. To this problem. That's part D. Part D says we're going to do y equals negative f of x. So to analyze it again, this is outside. And we know if it's outside, it's changing things in the y direction. So we're going to come in and multiply each y by negative 1. And that's going to do a reflection. So we'll see that as a reflection. So this point that's at negative 2, 0. Well, the y value is 0. Negative 0 is still 0. That doesn't move. But the point that's up there at 0, 2 is now going to be down here at 0, negative 2. And the last point that was at 2, positive 2 is now going to be down here at 2, negative 2. And what you're going to see is a reflection over the x-axis. So sure enough, we've looked at top to bottom. And those are our transformations. So again, to summarize, inside x, do the opposite of what it says. Outside y, do exactly what it says.